안녕하세요. 이번에 여러분을 이번 학기에 여러분에게 이제 컴퓨터 구조, 컴퓨터 아키텍처 코र्스를 가르치게 된 구건재라고 합니다. 저는 이번 학기에 고려대 컴퓨터학과에 임용되었고요. 제 주 연구 분야는 컴퓨터 아키텍처, 한국어로 컴퓨터 구조라는 그런 컴퓨터 아키텍처 분야를 연구를 하고 있고요. 뒤에서 좀 더 자세하게 이제 설명을 하겠습니다. 어쨌든 여러분 이 컴퓨터 구조 과목을 선택해주고 이렇게 만나게 되어서 반갑습니다. 물론 이제 저희가 교실에서 오프라인으로 지금 보지 못하고 코로나 사태 때문에 온라인으로 이렇게 제가 녹화를 해가지고 수업을 진행을 하게 되는 생각지도 못했던 상황이 발생을 하였는데, 우선은 이제 학교에서는 이제 2주 동안 필수적으로 온라인 수업을 진행을 할 거고요. 여러분들이 이제 교실로 나오는 일은 없을 것입니다. 그리고 2주 후에는 상황을 봐서 이 온라인 강의가 또 지속이 될 것인지 아니면은 오프라인으로 만날 수 있을 것인지 그건 잘 모르겠습니다. 어쨌든 저도 온라인 강의가 그렇게 익숙하지는 않기 때문에 빨리 끝나면 좋겠다라는 생각이 들지만은 그래도 이런 사태를 통하여서 온라인 강의를 시도를 해보고, 또 제가 인터넷 강의 강사들 선생님들처럼 그렇게 잘 하지는 못하겠지만은 그래도 온라인 강의 스킬을 조금 기르는 그런 기회가 될 수도 있다라는 생각이 드네요. 그리고 이제 말씀드리고 싶은 거는 이 과목은 처음에는 국강으로 해설이 되었다가 학교의 폴리시 때문에 이제 연강으로 이제 바뀌었습니다. 그리고 제가 로스터를 조금 살펴보니까는 인터내셔널 스튜던트도 이렇게 눈에 띄더라고요. 그렇기 때문에 제가 이후로는 영어 강의로 이제 진행을 하도록 하겠습니다. 물론 이제 영어 강의가 여러분들이나 저한테나 이렇게 쉽지는 않지만은 그래도 우리가 이제 엔지니어링 필드에 있는 만큼 이렇게 영어에 익숙해지고 또 영어 강의를 들으면서 또 지식을 또 쌓아가고 하는 것이 중요하다고 생각합니다. 예, 그러면은 이제 진행을 하도록 하겠습니다. So welcome everyone to enroll this course. This course is computer architecture course for undergraduate student. So my name is Gonjae Koo. I am an instructor of this course, and then I was newly appointed as an assistant professor in the Department of Computer Science and Engineering at Korea University this semester. And then my general research area is computer architecture, so I think I'm very happy to teach a computer architecture course this semester. So this is due to COVID-19 pandemic, so the university decides to offer only online classes during 2 weeks, but we don't know when this pandemic will end. So I don't know how long I provide the online teaching for this course. So let's start. Okay, so let's talk about the object of this course. The object of this course is exploring computer system architecture at an abstract level. So please focus on abstraction. I will explain later about this word abstraction, but as a computer engineering student, or computer science students, you should know the meaning of abstraction. This is a very important term used in computer engineering field. And then, so I don't know how you think about this course, but as an instructor, I set an object of this course as the object of this course is exploring computer system architecture at an abstract level. So please remind this object of the course and then please participate in this every class. And then I will explain what will be covered in this course. So basically, I will cover the concept of computer systems. So what is the computer system? So we already know about the computer systems. The computer systems run a general purpose application or a user programs. So meaning of a computer system is that the system can run programs made by many different people or many different users. So we already know about the computer system, and then this course will provide some knowledge on computer hardware system organization or computer architecture. So I will explain in more detail about some items covered by this course. The first, I will cover the performance metrics. So what is the performance metric? This is some criteria to compare the performance of different computer systems. So when we develop some new computer systems, then we need to compare the performance of this new system, because we research computer system in order to increase the performance of the computer systems or reduce the cost of the computer system, like power reduction or energy reduction. But as a computer runs general purpose applications or general purpose programs, it's not easy to measure the performance of these two different computer systems fairly. So we will learn about this performance metrics and how to compare the performance of different computer systems. And then this course will cover the instruction set architecture and machine language. So what is the instruction set architecture? So this instruction set is some protocol between software and hardware of the computer system. So protocol means some promise or contraction between two agents. So instruction set is designed for the computer system, and then if the software programs are translated into some computer instructions, and this instruction can be executed by the computer processors. So if there's some different instruction, if there's some instruction, undefined instruction is input to the computer processor, then the computer processor cannot recognize that this instruction, then it generates some exception. So this, if the programs are translated into some computer instruction set architecture, then we need to meet some criteria or some contraction of this instruction set architecture. And then computer systems, computer hardware only understand the machine language. So we need to learn how the instruction set architecture is mapped to the machine language. And then I will cover the arithmetic logic and the number systems. So the main operation of the computer system is to execute the arithmetic instructions. So what is the arithmetic instructions? It's the instruction for arithmetic operation such as addition, subtraction, multiplication, and division. Also, these arithmetic instructions require numbers for operand. So this is a basic operation of the computer system. So most of the computer system instructions supports the arithmetic operation. So and then computer system or computer processor it keeps the hardware units for calculating arithmetic operations. So in this course, I will cover this arithmetic logic and how the hardware units are built for the some arithmetic operations. So I believe you if you took the some digital logic design course, you already that course already covered the arithmetic logic. So I think this is some review of this review for the some digital logic design course. And so this is the very important concept of this course: in order processor architecture and pipelining. So actually, this inside of the computer processor has the many stages of some operations, and then these many stages are called the pipelining or pipeline architecture. And this is the very important concept for increasing the performance of a computer system. And so you need to understand about some pipeline architecture if you take this course. And then another important concept is the memory hierarchy. The most of the user data was some numbers and then programs. Programs are also data. So these data are stored in the memory systems, such as the internal memory of the processors or external memory, such as DRAM, or storage system, such as HDD or SSD. So we will learn how the memory systems are organized in the computer system. And then finally, we will learn about the parallel processor architecture. So most of recent processor has multiple cores. And then this core means each core runs the single threaded or single programs. So if the one chip has multiple cores, that means that this chip or this CPU can run multiple programs at the same time. So this is called the parallelism, or in Korean, 병렬화. So this parallelism is very important to increase the performance of the computer system. Actually, the throughput of the computer system. So this parallel process architecture is also critical for modern computer systems. So I will use the computer organization and design and RISC-V edition as a textbook of this course. So focus on this RISC-V edition. Actually, this textbook, Computer Organization and Design, written by David Patterson and John Hennessy, is very popular in the computer architecture, popular as the computer architecture textbook. And there are three different editions for this textbook. So the first edition is the MIPS edition, and then I believe other professors used this MIPS edition for the undergraduate computer architecture course. And then the second edition is the ARM edition, and I believe you're already familiar with the ARM cores or ARM processor, because these ARM processors are deployed in the smartphones, tablets, or some mobile computer systems. And then the most recent version is the RISC-V edition. So this RISC-V is the new instruction set architecture for the RISC generation 5. So actually, I will explain later, but actually, these authors, David Patterson and John Hennessy, designed the first RISC processors. And then these first RISC processors are designed by these professors and their graduate students. And then nowadays, they also design the open source instruction set architecture called the RISC-V. And then these RISC-Vs are becoming more famous in the industry or academic field. So I choose this RISC-V edition for for some cutting edge academic trend or some cutting edge industrial trend. And then I will use the lecture slide and the architectural simulator for RISC-V for these course materials. Then I will post my lecture slide after the class in the Piazza or Blackboard. And then also I plan to use the architecture simulator designed for RISC-V instruction set architecture. This is the photo of the authors of the textbook. So actually, David Patterson and John Hennessy are one of the most famous computer architects. So they designed the first RISC processor, as I said, and then they also wrote the textbook for this first RISC processor. And then this book is the first edition of their computer architecture textbook. It's not the same, but I also studied with this book, their book, actually their books, actually Bib's edition. So actually, this book is some classic textbook for the computer architecture. So, and then this David Patterson and John Hennessy received the Turing Award in 2018. And then Turing Award is the most prominent award in computer engineering field or computer science field. So you can find the Turing lecture presented during the ISCA 2018 via this link. So if you click this link, then you can watch some YouTube video, and this YouTube video records the Turing lecture. So Turing lecture is that, so if some scientists or researchers receive the Turing Award, and then they provide some one-time lecture for the audience for their research or some important concept in the computer engineering field. So it's a very good lecture. And then if you watch this lecture, then you can understand some history of the computer architecture or computer systems. And then also you can understand some recent trend in the computer architecture field. So I recommend you to watch this Turing lecture video. Okay, so there are some prerequisites of this course. So some recommendation. The first prerequisite course is the Digital Logic Design, COSE222. So unfortunately, I will not provide some some experiments with some real FPGA platform for this course. But if you understand about some digital logic design and then arithmetic logic design, then it will be very helpful to understand this course, knowledge provided by this course. Also, if you have the basic knowledge on programming languages, then it will be very helpful. And in this course, I will upload some examples of the programming code actually written in C language. So these C languages are used for write the operating system code or system softwares. So if you are interested in some hardware design or some system design, then you need to know about the C language. And then I will introduce about myself. So my name is Gonje Ku, and then in Korean, Gu Gonje. And then I'm an assistant professor in the Department of Computer Science and Engineering. And then, as I said, I was newly appointed as an assistant professor this semester. And then my office is located at Ujong Jeongbogan 403. My room number is 403. And then this is the official office hour after the Wednesday class from 3:30 to 5 p.m. But if you have questions, then you can use you can ask a question after each class. But unfortunately, we cannot have offline classes, so you can utilize some online class management tool such as Blackboard or Piazza. And then also you can email me through using my email address konjeku@korea.ac.kr. And then if you are interested in my research, then you can visit my webpage konjeku.com. And then as I said, my general research area is the computer architecture research. And then my detailed research area is GPU architecture and memory storage system architecture, embedded systems, accelerator architecture, and FPGA. So if you have interest in working on this research area, then you can apply for some undergraduate research intern or undergraduate researcher. Okay, for this course, I will utilize the Korea University Blackboard system, and then I will use this system for announcement and assignment management. So actually, I posted the announcement for this course. Also, I plan to post this lecture slide and some course materials on this Blackboard. But the Blackboard UI user interface is not fancy, so it's not very easy. It's not easy to use this Blackboard. So I will post the lecture slide, or I will post the assignment on the Blackboard, and then also you need to submit your assignment through your assignment result to the Blackboard. But I will use another class management tool, Piazza. So it is Piazza. So Piazza is some open class management tool, and then also I already made this course space on the Piazza. So this is the URL of our course, computer architecture course. So if you click this URL, then you can go to some Piazza. And then if you want to access this Piazza platform, then you need to sign up on the Piazza, and then you need the access code for this course. And then I set the access code as CODRISCV. And then so this is the Computer Organization and Design RISC-V edition. And then please join as a student, as you can sign up Piazza with your email address. So, and then you can use your Korean or Hangul. You can use Hangul. So you can use your Hangul name, or you can use your English name. This is the very convenient class management and discussion tool. So that means that I can post my lecture slide and then YouTube video link, while I can post some course materials on this Piazza platform. Also, students can post the questions on the discussion board. And then anyone can post questions and answers on the discussion board. So that means that TAs can answer for the question, I can answer for the question, and also any students can answer for the questions. So this is very good tool. So, and then if I don't know about this attendance point, then I heard that the Korea University does not consider about the attendance of the student, and then it depends on the student own behavior. So, but I don't know how to define some attendance point. But if you proactively post some questions or answers, then maybe considered as the class attendance point. This is the tentative grading policy. I will set the 40% of score for the midterm, and 40%, another 40% is for the final exam, and 15% for the assignment. And then I don't know. Actually, I set the 5% for the attendance point for the pop quiz or online discussions, but due to the Corona COVID-19 pandemic, it's not. I believe it's not easy to calculate this attendance point, post attendance point. So this attendance point can be included in the assignment point. So it actually is a tentative is a plan. And then for the exam, we will have two exams, midterm and final exam. The exams are closed book exam, and then no electric devices are allowed except basic calculators. So the basic calculator is only plus, minus, multiply, and divide can be done by the calculator, not scientific calculators. So, and then any cheating may result in F in this course, and this is very critical. And there is no mercy for any cheating during the exam or homework. And then you can answer in Korean or English in the exam. The problems may be written in English. This is some university policy. I need to meet the university's policy. So I will make the problems in English, but you can answer in Korean or English. And then this is the tentative schedule. We have 15 weeks of study schedule or class schedule. And then you can read the slide deck. And then, so actually, I plan to attend the ISCA during the late May to early June, so 1 week. So during this time, I plan to attend the ISCA. ISCA is some very popular computer architecture conference. And then if I attend the ISCA, then class will be cancelled. But problem is that this COVID outbreak is becoming pandemic all around the world. So maybe this ISCA conference also can be cancelled. So ISCA is cancelled, then class will not be cancelled. Then if I can attend the ISCA conference, then class will be cancelled. Just for your schedule. Okay, so this is some course introduction. And then I provide some information about this computer architecture course. So if you have any questions, then you can post your questions on the Piazza or Blackboard. Also, you can email me. Okay, thank you. Then I will record another video about for the some first chapter of the textbook. Okay, see you again.